First of all, know the derivatives of all 6 trig functions. Make sure you study those. Make sure you know those. That's just, we developed a couple of them, so it comes from somewhere, and you just got to spend some time with it. Find the derivative. So here we have the product rule. So h prime of x is first times the derivative of the second plus the second times the derivative of the first. And I didn't give any values for this, but that is how you would do derivative just on some general functions that we don't know what they are. They're just represented with some letters, F and G. So here's the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So G squared of x. So there's the quotient rule. Now I think maybe on the review I give some values that you got to plug in for those. And then dy dx here would be first times the derivative of the second plus the second times the derivative of the first. So there's the product rule. And I see over on the end there, tangent is sine over cosine. So I can do sine of x, secant squared x plus sine of x. Because the cosines will cancel. Tangent sine over cosine. Well, now we can factor a sine out. So sine of x, secant squared x plus 1. And I know that 1 plus tangent squared is equal to secant squared. So if I minus 1 over here, I could turn that into tangent squared, but it's not a minus 1 in there, it's a plus 1. But at least I considered it. We checked it for a possible Pythagorean identity. Decide if each function is continuous at x equals 2. Decide if each function is differentiable at x equals 2. Well, let's plug 2 in. 4 minus 1 is 3, so I have the point 2, 3. And here we have the point 2, 3. So we're going to say continuous, continuous at x equals 2. The top derivative is 2x, and when we evaluate at x equals 2, the left-hand slope or the left-hand derivative is 4. Now we want the right-hand derivative. F prime of x on the right side is 1. So not differentiable at x equals 2. Same thing over here. 4 minus 1 is 3. So 2, 3. 4 plus 1 is 5. So neither continuous nor differentiable at x equals 2. Neither. I don't have to check for differentiable because it's not continuous. If it's not continuous, it's automatically not differentiable. Maybe we can put that away. Find f prime of x. So f prime of x is equal to 3/4 x. So we multiply the front, reduce by 1. So we'll reduce the power by 1. That's negative 1/4. Well, we didn't start with negative powers. We shouldn't end with negative powers. So we'll send that down to the denominator. If a particle moves along the x-axis with position that for t greater than or equal to 0, find where the particle is stopped. So we want v of x, which is 2x squared minus x minus 1. And a particle will be stopped when the velocity is 0. So we'll factor this. I need a minus 1 here and a plus 1. So x equals 1. The other one is negative, and it says for x, it should say for x greater than or equal to 0. This next one is the limit as h approaches 0 of f of x plus h minus f of x all over h. And that is the formal definition of derivative. So we don't have to multiply it all out, collect like terms, cancel. We don't have to do any of that as long as we can find out what the function is. The function is actually sitting right here, and the function is sitting right there. So if we were to multiply all this out, do all that process, it'd be the exact same thing as doing this. Well, f of x is x squared minus 3x, and the derivative is 2x minus 3. So there's the answer right there. The answer is 2x minus 3. But we know the shortcuts to all this, so we don't have to go through all that process. So the tough part about this problem is looking at this and knowing to get this and knowing to do that. If you know how to do that, there's very little to do, very little. But you got to recognize it. Any questions on that one right there? Find the derivative. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Always start with the bottom on the quotient rule. Bottom times derivative of the top. Oh, what can we do? Not much to do here. We can take out an x. So 2 sine of x minus x cosine of x over sine squared. That's pretty much all you can do with that one. All right, we have a chart. We have time and temperature. Find the average rate at which the temperature is changing at 3:20. Well, we don't have any information about 3:20. That's between 3 and 4 o'clock, let's say. And the best we can do to find instantaneous is just do average and call that the answer. It's the best we can do. So 47 minus 50 over 4 minus 3 is negative 3 degrees Fahrenheit per hour. That's the best we can do. So we'd have the exact same answer for anything in between 3 and 4 would be the exact same answer. We can't do any better than that. What is the least amount of time the temperature is 41 degrees? It could have been more, like between 50 and 47. It could have dropped all the way down to 40 and then back up to 47. We don't know that happened. So the only one we know is right here between 45 and 40. So we say that, first of all, temperature is continuous. We can say the temperature at 5 o'clock was 45, and the temperature at 6 o'clock is 40. So we state some values. We're saying, hey, at 5 o'clock it's 45, and all of a sudden at 6 o'clock it's 40. That means somewhere in there it was 41. And we can say by the intermediate value theorem, the temperature was 41 once. One time. I don't see anywhere where it could have been, or it's guaranteed to be 41. It could be, but not guaranteed. Only one time that's happened. Well, now let's see, it says use a tangent line to estimate the temperature at 1:30. We don't know what the temperature was at 1:30. The temperature went from 45 to 48. So it went from 45 and it got up to 48. And we assume that it probably warmed up somewhat gradually, unless a storm rolled through and did some crazy stuff, but we'll assume that didn't happen. We're going to take a tangent line and we're going to use the y value to estimate the value of the curve. Now it's going to be off, it's only an estimate, but it's the best we can do. All right, so we need a point of tangency. let's pick 1 o'clock as the point of tangency. So 1 o'clock gave us 45 degrees. So there's the point of tangency. And now how much did it change? What was the slope we're trying to find now? So from 1 to 2, 1 to 2 is 48 minus 45 over 2 minus 1. We can't find an instantaneous rate of change. The best we can do on a chart is do average. So the slope is 3. All right, now we have y minus 45 is equal to 3 times x minus 1. There's the tangent line we're going to use to estimate what probably was a curve. The chances of being exactly linear, pretty slim, but maybe. 130 is 1.5. So y minus 45 is 3 times 0.5. 1.5 minus 1, that's 0.5. Half of 3 is 1.5. So 46.5 degrees Fahrenheit is our best guess using a tangent line. Questions on that? A particle is moving along the x-axis that any time t greater than or equal to 0, its position is given by this function right here. Find the velocity. T squared minus 10t plus 24. Find the acceleration. 2t minus 10. When is a particle at rest? 0 is equal to, let's see, t minus 6 and t minus 4. So I factored that. I set that equal to 0 and factored the velocity. So t equals 4, t equals 6. How do I know that? V of t is equal to 0. That's how I know it's stopped. That's the justification. Find the speed when the acceleration is 0. So here's acceleration. We set that equal to 0. So t is equal to 5. And then they want the speed. So if we plug that, I want v of 5. 25 minus 50 plus 24. That's negative 1, so the speed is equal to 1 when the acceleration is 0. 1 mile per hour, foot per second, whatever it is. We didn't give labels on this one. Find the intervals on which the particle is speeding up and slowing down. Well, that's a combination of velocity and acceleration. Excuse me. The zeros of velocity, we found those, are 4 and 6. So we're at 0, 4, and 6. 0 is where we're starting. The acceleration, the 0 is 5. So we're right here at 5. So we have these three are either zeros of the velocity or zeros of the acceleration. Velocity, acceleration, velocity. I'll make a little note there. Let's plug 1 into the velocity. Let's plug 1 into both of them. 1 minus 10 is negative 9, plus 24 is certainly positive. So from 0 to 4, we have positive velocity. And for acceleration, we have negative acceleration when we plug 1 in. So between 1 and 4, we're slowing down. They oppose each other. Well, then velocity can change over 4. So 4.5. 4.5 squared minus 45 plus 24. Negative. So velocity can change to negative, but that's not a 0 for acceleration. That should still be negative. As a matter of fact, that's 9 minus 10. It's still negative. It can only change over zeros. Anyway, here's a 0 for the acceleration, so the velocity can't change, but the acceleration can. So 5.5 That's 11 minus 10. Now your acceleration is positive. And finally over here, the acceleration is not going to change over 6, but it can change, velocity can change over 6. So if I plug 7 in, 49 minus 70 plus 24, that's 21 plus 24, that's negative 21. So now velocity is positive. All right, any questions on just getting the positives and the negatives? Anything confusing there? Go ahead.
So if they're the same, they're negative. If they're different, they're positive?
If they're the same, it's speeding up. If they're different, it's slowing down. All right, so I haven't answered the question yet. Let's go slowing down. That's from 0 to 4. And they oppose each other from 5 to 6. 5 to 6. And speeding up, they are the same. They're helping each other from 4 to 5. And then they're both positive from 6 to infinity. I had a question. I think that's it for me. I had a question last period. A few students asked this, so I thought, well, I'll assume you guys, maybe a couple of you have this question. Going towards or away from the origin is a comparison of the position with the velocity. So there's the origin at 0. So if your position at, let's say, 5 seconds is 10, and your velocity at 5 seconds is negative 4, that means your position is over here at 10, but you're going left. So you're going towards the origin. If your velocity at 5 was 7, that means you're at 10 and you're going away from the origin. You're going to the right. So going towards or away is a comparison of the position versus the velocity. Any questions on that? Hopefully that helps with that question. I know it's on the review. I'm not sure if it's on the test. All right, let me shut this down. Grab your Chromebooks, please.